All right, I'm just tagging on a little bit to that section 7.5. It's not that hard. So we'll just call it section 7.5. We'll call it part B. Is that all right? Because we just didn't quite get to it yesterday. So let's draw a triangle. Now this time, we're going to just take one triangle. Before we took two triangles, right? We compared two triangles to each other. This time we're just going to look at one triangle. So just looking at the one in the book, something like this. All right, so there's one triangle right there. Now what they're going to do is they're going to draw something that we talked about before. They're going to draw an angle bisector. But this time we're just talking about one triangle. Because some of you guys are probably looking at this and saying, well, yesterday we talked about angle bisector. Why are you doing it again? Because yesterday we talked about the angle bisector of two triangles, two similar triangles. Would you agree? This time we're just taking one big triangle and we're going to do the angle bisector of that one big triangle. I'll just make it look like the one in the book. They start at this angle right here and they bisect this angle. We talked about this yesterday. So I'm looking to split this angle into two equal angles. It doesn't mean that you're hitting the midpoint of the other side. So let's say about right in there. It's pretty close. So what did I just do? I found the angle bisector. Now watch this. Let's call this little part A and B. We'll call this whole side C. We'll call this whole side D. All right? You guys watching? All right.
Sir.
Doesn't seem like some of you are. Gabby, you need to stop with that, please. I let it... Well, it sure takes me off my game, I'll tell you that much. Okay, so we're not going to do that. So let's take a look. If you have an angle bisector right here, it says... it separates the opposite side into two segments that are proportional to the lengths of the other two sides. What in the world does that mean? It means this. I can compare, to see how this angle bisector hits this side right here. It doesn't necessarily hit in the middle right there. Okay, so this is not, it doesn't mean that A equals B. See that? Looks like A is a little bit shorter than B on this triangle, doesn't it? All right, so it doesn't mean it hits it right in the middle, but it hits it so it's proportional. These two segments, this A and this B, are proportional to the other two sides of the triangle. So you say, well, what does all that mean? Okay, you're saying all these big words. I don't know what it means. Well, we've been talking about proportion for a long, long time, so you should know what it means, but that's all right. We'll still take a look at it. These two segments right here are proportional to the other two sides. What does that mean? It means if I take the ratio of these two sides, these two segments, it's going to equal the ratio of the other two sides. So let's compare these two to each other. Let's compare A to B. Everybody see that? This is the only time it works, when you have one triangle and you bisected this angle. So if I bisected this angle, it hits right there. It splits this side into two little sections. This little section A and this little section B. If I compare A to B, what do you think that's going to equal? A to B is equal what? C to D, that's right. Why not D to C? Because look, the C is attached to the A. Do you see it? See how it touches? So the A and the C go together. So if A is on top, the C goes on top. If the B is on the bottom, then what? The D goes on the bottom. And then you can solve. Does that make sense? All right. Here's another way you could do it. If you wanted to, you could compare, I'll put an OR right here, O-R. If you wanted to, you could take A and compare it to C. If I did it that way, what would I have to do with B? I'd have to compare B to what? To D. So if I wanted to, I could compare it that way. A to C equals B to D. How do I know if that's going to work or not? Well, I cross multiply and I see. Watch, if I cross multiply, what do I get? I get AD equals BC. Is that the same thing that I get over here if I cross multiply this? Absolutely. That's AD and that's BC. So if they cross multiply to be the same thing, then they're the same proportion. All right? What can I not do? I can't compare A to what? To D. All right? Can't do that. And I can't compare B to C. You follow me? Yeah. Don't do that because they have nothing in common. This little A right here, do you see that? Doesn't have anything to do with this side D over here. And this little B right here doesn't have anything to do with side C, so we can't compare them this way. These are the two ways you can compare them. So now let's do one of the problems that you had on last night's worksheets. Yeah, that's pretty simple, isn't it? It's really not that hard once you know what the relationships are. The math is really not that hard. And in fact, all of geometry, I don't think the math has been all that difficult. It's knowing what to put where. Would you agree? And we've been saying that all year long. And let's do this. Let's make an angle bisector. So again, I'm trying to bisect that angle up top here. So I've taken that angle and I've bisected it. And they put some numbers in here. They make this M. They make this little bit 8. This one's 12. And this one's 26. Alright? So what are we going to do? Well, look, here's the angle bisector, and it splits the side into these two parts, 8 and 12. I would just compare them to each other. I would go 8 over 12. Right? So I'm comparing this one to this one. Everybody see that? What's that going to equal then? If I compare these two to each other, what do I do up here? M over 26. Cross multiply and you're done. Right? Pretty easy. I don't know. For those who understand this, watch. You actually don't even have to do this whole cross multiply. If you want to get M by itself, what is that 26 doing to the M? Right, it's dividing. So how do you get rid of something that's being divided? Just multiply it. Multiply this by 26, multiply that by 26. Would you agree? All right. And then you can put that into a calculator and get an answer. Or you could probably work this thing out. Actually, this doesn't come out quite nice and even. So we'll just put it into a calculator, I guess. Almost hate to do that, but I will. So it's 26 times 8. Watch, 26 times 8. And then I think you can just hit divide, but I always like to hit equals first. And then divide that by 12. So 17 point. What's 3 repeating like that? It's 1/3, isn't it? So you could write 17 and a third. Or if you wanted to, I'll let you write 17.3 if you want to do that. I'd be fine either way. Alright? Or if you really wanted to, watch, let's do a little practice with some fractions here, since we got a few minutes. You could write it like this. Let's see what cancels here. What goes into, let's say, 12 and 8? 4 does, right? Sorry. 4 goes into that 3 times, and 4 goes into that twice. Agreed? What else goes? That's it, right? Yeah, 3 doesn't go into 26, does it? Nope. So that's it. So what do? We multiply across. 26 times 2. Can you do that in your head or not? 52. It's 25 times 2 is 50, right? You agree? Okay. And then over 3. So you could write your answer like that if you wanted to. You didn't need a calculator at all, did you? That wasn't that hard, right? You just took 4 into 12 and 4 into 8 and multiplied 26 times 2. So you could have kept it like that. 52 over 3 is the same thing as 17 and a third. So I would accept this. That would be fine. That would be fine. And that would be fine. I don't care. Actually, I would rather. If I was to do it, I would probably do it like that. But any of those, I would give you credit for. Make sense? All right. So you should be able to do number 8 on your own. Go ahead and do that real quick before you turn it in. Okay? If you haven't done it already. And look, I showed some work, didn't I? I set stuff up, didn't I? All right. Now, make sure you at least just set it up. You could do the work in the calculator. People all the time say, Mr. Amrick, I did it on the calculator. I'm like, yeah, but what did you put in the calculator? That's what I want to see. I want to see your work. I want to see what you put into the calculator. And that right there tells me what you put in your calculator. That's your work. That's all you need. All right? I'm not asking for a whole lot when I say show your work. I just don't want a whole bunch of answers just written down, because anybody could just sit there and write down the answers as I read them off to you, right? As we do at the beginning of class. And many of you definitely try it, all right? But many of you get many points off for trying to do that. So I don't see why you keep doing it. Well, I do, because you just are too lazy to do the homework and you just don't want to try. That's why. I mean, I know why. It's just don't think it's wise, do you? All right. That's it. I'm giving you another worksheet today just to practice it one more time. So it's still section 7.5. I thought about doing a new lesson today, and I just thought, since it's a short week, I thought we'd pace ourselves this week. I don't know. I think we're skipping 7.6, and then we're going to do 7.7, and we'll be done, okay? So we're going to go to 7.7 after this. So this is page 92. It's a worksheet, page 92, and that's what I'll give you right now.